Good day, learners. In this video, we are continuing with inclination. This is the second lesson on inclination. Now we are working from sketches and we are doing a little bit of problem solving. Before we jump in the previous video, we started looking at inclination. If you haven't watched that, I just suggest go look at that first, where we work out the inclination angle of between 2 points, and just practice to do that with the formula and how to do with specific cases of negative and positive gradients. Now what we are going to do is we are going to calculate angles on sketches using the inclination angle. Now before we do this, to find inclination angles on sketches, I just want to mention that it's important that you know that the angle of inclination is always measured from a horizontal line. It can be the x-axis, but you can also draw any horizontal line across this line. And then from the positive x-axis side, from this side in an anti-clockwise direction to the line, that is how you measure an angle of inclination. So for this line, you see this angle here is the angle of inclination. For this angle, between the positive x-axis anti-clockwise to the line, this there is the angle of inclination, not that one. This is not an angle of inclination at all, right? Because it's between two lines. Angle of inclination is always of a specific line between the horizontal from the positive x-axis side in an anti-clockwise direction, not from a negative x-axis side. This is not angle of inclination, this there is. Right, so just be aware of angle of inclination, that angle from the positive x-axis side in an anti-clockwise direction. Same as how you measure angles on the cast diagram, right? There is your 0, and then in that direction 90, 180, it grows bigger. So you measure an angle from this side. So if I have a line there, the angle of inclination is that there. Right, if I have a line there, the angle of inclination is that. If I have a line there and it doesn't really go through the origin, you can draw a little cast diagram part there and then think of there's my angle of inclination, right? If you have a line that does not cut the x-axis at all on the sketch, you can do one of two things. You can either just extend the line to the x-axis so you can see the angle of inclination, or there where the line stops on the sketch, you can draw a little cast diagram to see the angle of inclination there if it's necessary. So you can extend lines, you can extend, you can draw a axis or a horizontal line, but it's important to know any horizontal line from the right hand side of that line in an anti-clockwise direction, that is where you find your angle of inclination. Right, so we're going to do two questions from this exercise 4. I'm going to do number A and D. Number B and C is very similar to number A, so you can try them at on your own at home. I'm going to do number A, and then number D is a bit tricky, but we'll deal with this. Okay, let's start with number A. I've redrawn the sketches here so I can scratch on them if needed. So I want to calculate the angle theta, right, which is not on the sketch an angle of inclination. Where are my angles of inclination? There, let's call that X, and there, let's call that angle Y. Right, so I can get x and y with inclination, and then the theta you must get with Euclidean theorems. Now I can immediately see this is a triangle, this is an exterior angle which is equal to the opposite two interiors. So if I have x and y, I can use that to calculate theta, and that's what I'm going to do here. Okay, so let's start by calculating the gradient of the line AB here. The gradient of AB, difference in y, 5 minus 0, over difference in x 0 minus negative 3, which is 0 plus 3, and this is then 5 over 3. Positive gradient, scenario 1, to calculate inclination, and now the angle here is x. Right, so tan x is equal to the gradient, which is 5 over 3, meaning that angle x is shift tan 5 over 3, and I can type that into my calculator, shift tan 5 over 3, and that gives me 59.04 if I round it off. Right, so x is 59.04 degrees, it's an angle. Okay, next I'm going to work out x by working out first the gradient of AC. So I want to work out that angle there. So I'm going to start working out the gradient of AC, difference in y, 5 minus 0, over difference in x, 0 minus 4, and that is negative 5 over 4, which means then that the tan y is equal to negative 5 over 4. Now this is scenario 2 of working out inclination angles. Whenever you have a negative gradient, you must remember in the step where you work out the y to take 180 plus shift tan of the negative gradient. Whenever you have a negative gradient, you must add 180 to that angle. Right, so I have 180 plus shift tan negative 5 over 4, and that gives me 128.66 if I round it off. Right, so the y is going to be 128.66 degrees. Right, now the y is the exterior angle, and y is equal to x plus theta. Y is equal to x plus theta because of exterior angle of a triangle that's equal to the opposite, the sum of the opposite two angles. So theta, if I jump the x over, theta is going to be y minus x. So I can write theta as y, which is 128.66, minus x, which is 59.04, and you can use your calculator. 128.66 minus 59.04. On my calculator it gives me 69.62. 69.62 is the value of theta degrees. Okay, right, so that is question 1a. Next we are going to look at 1d, which is a bit more challenging. I want to work out this theta. Now let's first just put in our angles of inclination here. So you see this angle here is, I'm just going to move the C there. Okay, this point C cuts at 5, 0. That point B cuts at 0, 2. I'm just going to put in the coordinates as well, and A is the point 0, negative 6. Okay. So this here, let's call it alpha. This angle here is the angle of inclination. I want to calculate that. This line here, well, you can either draw just a perfectly horizontal line there, and that angle is going to be the angle of inclination of this line, which you see is the same as that bit there. So that bit there is also going to be beta, and then that bit, can you see, is going to be 180 minus alpha, because that's alpha, and angles on a straight line gives me 180. So the theta consists of 180 minus alpha, the inclination of line BC, plus then the beta, the inclination of line AC, is going to give me the size of theta. That's one thing you can do. Or something else you can do is you can extend this line here, right? And that's then, that beta is the angle of inclination of this line. And then you see the vertically opposite angles gives me that this is also beta, and then I can use the still the 180 minus theta to get that part, and that part is beta, and then add that. Right, so that's two different methods you can use there. Point is, I need the inclination of line BC. So let's start with that. Gradient of BC is difference in y0 minus 2 over difference in x5 minus 0. So this is negative 2 over 5. Scenario 2, if you have a negative gradient, this line, the inclination I called alpha. So I'm going to use alpha. Tan alpha is negative 2 over 5. You must just remember when you work out alpha to add 180 whenever you have a negative gradient. Shift tan of negative 2 over 5. And I'm quickly just going to type this into my calculator here. It gives me 158,198, which I can round to 20 degrees. So that's the angle alpha, right? Then 180 minus alpha is going to be 21,801, so 21,80, right? That's then if this is 158, then this part here is, you see, 21. Okay, that part, because I need the theta, I've got this little angle here, I still need that angle, which is beta, the inclination of that line. Okay, so next I'm going to work out the gradient of AC using the coordinates of A and C, difference in y, 0 minus negative 6, over difference in x, 5 minus 0. So this is 6 over 5. Positive gradient, I can just say tan beta is equal to 6 over 5. So beta is shift tan 6 over 5, which is 50.19. And then the 180 minus alpha, that 21, plus the 50.19 is going to be the theta. So theta is 21.8 plus 50.19. I'm just quickly typing it into my calculator. And then that gives me 71.994, which just rounds to 71.99 degrees. So that's the value of theta. And this is how you deal with inclination on sketches. Normally in grade 11 and 12, when they ask inclination, they're not going to just straight up ask the inclination angle. They're all going to ask something else that you must get by using the inclination angles and Euclidean geometry type things. Okay.